Assalamu alaikum. Now we finalize distinguish between hydrated ion and hydrated ion radius and the ion radius. Here potassium has a higher ion radius while lower hydrated ion radius, and in contrast lithium. So the ion radius of potassium is higher than lithium. Here is the ion radius of potassium and the ion radius of lithium, while the hydrated ion radius of lithium is bigger than potassium. Now we are talking about absorption phenomena, and I defined the absorption phenomena for you, that accumulation of material on layer between solid surface and liquid. If if the mechanism is not known, then there is an expression should be used. This expression called sorption. The sorption is used when you are not able to distinguish between adsorption, precipitation, and polymerization. So sorption is commonly used as a general expression to indicate adsorption, surface precipitation, and polymerization if the surface adsorption mechanism is not known. So some important definition should be recognized. The first is adsorbate. This is the material which is adsorbed to the solid surface, the substance that accumulates on the surface. Adsorbent is a solid surface on which material can be accumulated. And in our case, that should be a soil particle called as adsorbent. Adsorbative is an ion or molecule that has a potential for adsorption on the surface. If you are using the expression of sorption, then the sorbative, sorbent, and sorbate should be used instead of previous three expressions. These show you let you able to distinguish between three definition. The sorbent is a soil particle. The sorbate is the ion or molecule which is accumulated on the surface of the soil particle. Sorbative, the ion has the ability to adsorb to the soil, or to sorb in the soil. The importance of soil adsorption process. Actually, we are making a lot of research using adsorption mechanism for remediation of and purification of water, purification of wastewater, and from pesticide and nutrient, our heavy metal. So, for example, we put a biochar or soil clay, some type of soil or minerals like zeolite to the wastewater, or both the wastewater on a column contain pesticide, column contain clay minerals like zeolite. Then we let the wastewater pass through the column. Some contaminants absorb to the metals, and we can also make some batch experiment by shaking the wastewater with the light and determine the absorption capacity of the absorption efficiency and capacity of the minerals. So importance of soil absorption processes is to determine the amount of nutrient, heavy metal, pesticide, and organic molecules that accumulate on the surface of the soil particle. Also study the effect of the transfer and mobility of nutrient and pollutant in the soil. As absorption processes affect the electrostatic properties of the soil system, for example, the flocculation and dispersion of the soil colloid. Forces influencing the absorption processes in soil system. Physical force include van der Waals force, ion exchange. Chemical force include inner sphere complex, hydrogen covalent bonding. Surface functional groups. It is a chemically active part of the molecule that is associated with a crystalline structure of the solid phase. There is some molecule on the surface of the solid phase able to absorb some other molecule or ions. Surface functional groups play an important role in absorption process, and these groups can be divided to organic surface group like carboxyl, carbonyl, phenols, amine, which presents in organic matter. Inorganic surface functional group like siloxane group, oxyhydroxide, toluenol, and aluminol. These found on clay mineral and on tetrahedra, as you studied before. As you know, tetrahedra has Si or 4 if it is single, or octahedra, and so on. Phyllosilicate and so on. Surface group can be gain or lose proton by absorbing hydrogen ion or hydroxyl ion. In this case, called pH dependent, because it depends on pH dependent because it's differ. The surface charge depend on the pH, as I will explain. So here some surface group: OH, CO, COH, NH. It may gain H or lose H according to the pH. Here is the phenols, if it is carbon, and this O and this H. Carboxyl groups and so on. I think I explained this before. Let me know now. I explained that the pH dependent and independent charge in previous lectures. How can we make experiment of absorption? It's easy, just to get a beaker and put the clay mineral on the beaker and put a different concentration, include zero concentration, this called a blank, and at one concentration of the contaminant. For example, if you are studying absorption of potassium, for example, so you will put a solution contain, for example, you take 10 gram of mineral, zeolite mineral, for example, it's a clay mineral. So put 10 gram of the soil sample, put here distilled water free from contaminant, from potassium. If you are going to make absorption of potassium, ammonium, or heavy metal like copper, or pesticide, for example, DDT, for example. So if you are, let us talking about a heavy metal like cadmium, for example. So if I would like to make to study the absorption of cadmium into the zeolite, how we can do that? This is easy, just to prepare a beaker. This beaker, for example, put a 10 gram of zeolite and 50 milli here, because it is blank, it's empty from any contaminant. 50 milli of distilled water. Here put 1 millimolar of cadmium. Here 10 millimolar and 100 millimolar. So you should shake for a certain time. So in that, if you want to determine the equilibrium time, so you have to know to do another experiment called kinetics experiment. In kinetic experiment, you will be able to determine the time of shaking. So just know that there is an experiment called kinetics experiment. Not necessary to know it deeply, but if you are going to enter to the to be a specialist or scientist on soil science, then we will explain you how to make a kinetics experiment. So what I would like to say here, that just that the time of shaking between adsorbent and adsorbate should be calculated or determined by another experiment called kinetic experiment. So here I'm talking about isotherm experiment, adsorption isotherm. Isotherm means that in constant temperature, just we prepare a beaker and put the different concentration of contaminant with certain weight of a material want to let the contaminant absorb to it. So which is called adsorbent. Here I told you I make zeolite and cadmium. How we calculate the adsorbate quantity or adsorption quantity? Can easily calculate that if you have a first concentration, initial concentration in solution, the volume will be constant on both here and there. But if the volume is different, so you have to divide, to multiply in volume minus the final concentration on solution, multiply the volume. But if the volume is the same, so you can use only V on the last. C initial minus C final, multiply volume over the mass of the adsorbent. Okay, so the quantity of Q is the quantity of adsorbate, is the quantity of the material adsorbed to the adsorbent, the quantity of adsorbate on the adsorbent. How it's easy, just to if you add 10 milligram per liter or 10 millimolar and make shaking with adsorbent and found the final concentration 2 millimolar, then the amount adsorbed to the adsorbent, to the material, to the soil particle or clay mineral, will be equal to. Is this correct? It's easy. Just you put as a known concentration and put this known concentration to the clay mineral and shake and filter. Take the supernatant and measure the remaining part of the contaminant. The final, the initial concentration minus final, will you get the adsorbate one, adsorbate